So 4.3 uses the ideas of increasing and decreasing to figure out minimums and maximums. We kind of already talked about it, but this is the idea. In a nutshell, assuming you already saw the videos. And some good curve there. All right. So basically, remember how last time we talked about critical numbers and how those critical numbers could be extrema values, which are these peaks and valleys, right? Y'all remember this? No. As I, if I found the derivative of this random function and I plugged in any value below this point, right over here somewhere, any x value, all the derivatives would be positive because it's increasing. Over here, the derivative would be zero, which is how we found critical numbers last week. Okay. Now, as you can see, right after this, we start to go downward. So what do you expect the derivative to be after the peak? Right? You see how it's decreasing, pointing downward. So back to college algebra, if y'all don't remember anything, right? We're going upward, left to right. It's an increasing in those areas. And then at maximums and minimums or extrema values, it's constant. Right after it starts to decrease, it's pointing down. Over here, notice it begins to increase again. Do you all see any patterns here? Well, they're all the same size arrow. I just can't draw. But do you see how before the maximum we have increasing and then decreasing? So that's what this first test does, is you check, am I going up and then down? If so, then I have this peak. If it's going down and then up, then I have a minimum. So do y'all see what I'm talking about? That's the essence in a nutshell what the first derivative test is. Positive to negative, max. Negative to positive, min. Before we move on, is that clear? Yeah, because a lot of the chapter is going to keep asking, find max, find min. If they mention first derivative tests, then you got to figure out, okay, where am I increasing, where am I decreasing? And then you can talk about minimums and maximums. So the homework begins by asking, can you figure out when a function is increasing or decreasing? Identify the open intervals on which the function is increasing decreasing. F of x will be, this is start with something simple. All right, so let me write step one. Is find the derivative. What is the derivative of f?
Two x minus 6.
Yeah, 2x minus 6. No big deal, right? This whole class has been find derivatives. So now we're going to apply it in chapter 4. Find the critical numbers. Do you remember how to find them? We said the derivative equal to 0. So here we go. I don't think I have enough space for step 3 here. But y'all fooled the first 2 steps. Is that fine? Good. Let me know. Something doesn't make any sense. Just tell me. Or if you need a second. Let me go ahead and use the first derivative test right away because you can do it all at the same time. Use the first derivative test to test around the critical numbers to determine if it is a max minimum. Okay. Did we solve the critical numbers? I forget. Kind of. Yeah, we did. We said the critical number was 3, right? It's my magical number right there. So the way you use the first derivative test is test right after and right before. So you can pick any number you want. I recommend pick super easy numbers. I guess 4. I don't know. 0 is always easy. Anything not too big is great. So what you gotta do is plug these in. I guess you can call this step 4. Well, yeah, that's what we're doing right here. So we're testing around the critical numbers. So it's part of step 3, I guess. Yeah, that's fine. So f prime was 2, yeah, 2x, 2 times 0. Dang it. Minus 6, right? Yeah. Which will be negative 6. So we are negative over here. Now check the sign at 4. We are positive over there. So that's how you use a first derivative test. You just check before and after. That's it. So over here, we are decreasing. And then suddenly we are increasing, right? After the critical number. And it's kind of a shitty drawing, but you get the point, right? You see how if we go down and then up, we have a minimum. So minimum at 3, column something, I don't know what 3 is. There is no max though. So there was only one critical number. So you would just say max in a. Now, if you want the y value, minimum, you got to plug it into the original. So f of 3 will give me original as x squared. Yeah. Minus 6x. I don't know the last number. 16 or something. Negative 25, right?
Where did the 2 go?
2. Well, this is the original f. We're plugging in 3
Oh, now I see.
because the original function gives you a location, the derivative gives you increasing or decreasing or slopes. Okay, now they didn't ask for any of this in the homework, but we're doing it all. Might as well start practicing early. So the real question was, where are we decreasing? Where are we increasing? Okay, so check it out. So before 3, we're always decreasing, just coming down forever. Then after 3, we're always increasing, right? That's how you read this. So you would say, well, I'm going to be decreasing negative infinity all the way until I get to 3. And then I'll be increasing every after 3. That's it. That makes sense. No, if you graph it, it's super obvious, but they want you to show all this work and understand. Any questions on the process? Let's move on to number 2 then. Let me graph this real quick before we move on. Let's just get another idea. Yeah, I'll see the graph.
Yeah, I see the graph.
So there's a minimum, right? Put minimum. Yeah, I did. 3 at negative 25. So you can see we're decreasing negative infinity all the way until I get to this extrema value or critical number. And then right after start to increase. So that's how I got those 2 intervals, right? You can see it on the graph, but we're using the derivative to guide us. Any question on that? Let's do another one. Okay, this is number 8 in your homework. Do a hard one here, kind of. We're doing this function 2x cubed plus 6x squared minus 48x. Part A says find the local max and min. B, find the intervals for increasing, decreasing. All right, so step one, find the critical numbers. So I'm going to try to streamline this a little bit. Find critical numbers, which means take a derivative, right? So subpart derivative, I'm going to go ahead and do it for you. This will be this, right? 6x squared plus 12x minus 48. Step two is set it to 0. So 6x squared plus 12x minus 48 equal to 0. Factor this and solve. All right. So factoring, they all have a 6 in common. So we'll get x squared plus 2x minus 8, right? Factor your trinomial. If you forgot how to do that, let me know. That will be what? Okay. So we have two critical numbers. Any questions on the algebra? Is that okay? Or the derivative? Okay. That's step one then. Yeah. So we will test around these two critical numbers, x equals -4 and x equals 2. See if I can put it in here. The two critical numbers. So choose any numbers in between and after, so it doesn't matter. I'm going to choose the easiest ones. So when you do this on your own, if you see zeros available, take it. I just pick numbers really close. It's good enough. Okay. Here we go. Okay, so let's do -5 first. So that'll get us what? 25 times 6 plus a -60 minus 48. It's 42, right? I think so. Task 0. It's an easy one. Now try 3. That will be 6 times 3 squared plus 12 times 3 minus 48. 32. Double check the other one. Cool. They're both 42. Well, the number doesn't matter, the sign does. So we're plus, minus, plus, right? So we have increasing and then decreasing, right? We have continued decreasing and then increasing. So over here, we have a maximum and a minimum. Do y'all see how the first derivative test works? So we have maximum at -4, comma something, minimum at 2, comma something. Let me look up the answer here just to save some time. This would be 160 and -56. There we go. We're increasing from -infinity all the way until 4, and then we start to decrease. And then we begin to increase again after 2. Do you see how we made this interval? Does it make sense? We're decreasing after 4 until 0. And then again, no, actually it's 4 to 2. That's it. Any questions on the example 2? Okay, so what I recommend is graph them first, just so you know the answer, and then try to solve them using your calculus. Okay. So looking at the answer, like, okay, I know what it is, but how do I get it? How do I prove it using the first derivative? Okay. It's basically what you're doing. Are there any questions on these ideas? Do you know how to find critical numbers? Can you find out where we're increasing and decreasing using derivatives? Can you find maximums and minimums? Okay. And we'll stop this lecture here then. Do y'all have any questions on any other sections? Is everything still open, or you guys need any more time on anything? You guys good?
Sir, can you reopen my the review for me?
Okay, let me see. Let me check.
Because I had to come back to my mom's.
So I think it's still open. Let me,
Like, I'll message y'all, email you.
yeah, it looks like all the homework is open, but I think it's in Canvas, right?
Yes.
Okay,
Like my time, it timed out on me.
okay, what's your last name?
Via
All right, 1 second. Test 1 or 2?
for the test reviewed number 2 for tomorrow. Yeah, that's due tomorrow.
Okay. Yeah, I should let you take it again. I'll give you. I'll extend it a few more days just in case. Just redo it. All right. So yeah, you have a week from today to finish it. Soon. I mean, you don't need the week, but it's there. Um, it should let you try it again. Test 2 is also due tomorrow. Are y'all good on test 2 at this point, or? Chapter 4, yes. I feel like we're just getting into it anyway. I'm giving you all a little more time on test 2, but we're moving on, so don't wait too long. I'm hoping most of y'all should already have it done, but if it's not, you have a little more time. Don't need to worry about that anymore. Chapter 4, though. Looks like some of them are closing tomorrow. Right. Yeah, I'll reopen chapter 4, but I'm assuming 3 at this point. We're moving on. For 1 through 4, 3 will close next week.